We are going to be starting our new chapter, chapter 2. So I sent out a digital copy of these notes outline. So make sure that you make a copy of it in your own Google Drive and follow along with me filling in the answers. Okay, so to begin, we're going to start with motion. So motion is just the change in position relative to a reference point. Okay, or sometimes it's called the origin, but it's your point of reference. Okay, so we must assume that whatever the frame of reference is, that object is fixed in place. So the most common frame of reference that we use is Earth. Okay, so if I was describing the motion of a car, let's say, and I say that it's going 50 miles per hour, okay? That's relative to the Earth, okay? So relative to a certain spot on Earth, it's traveling 55 miles per hour, okay? If you think about frame of reference, motion is just relative to the observer and their reference point, okay? So it's all relative motion. So if you were sitting in a car that was traveling, let's say the 55 miles per hour, relative to the Earth, you're moving 55 miles per hour, okay? Even though relevant reference to the car, you're not actually moving, right? Because you're just sitting in the car. So you wouldn't say that you're moving, but relative to the Earth, you are moving at 55 miles per hour because you're inside that car that is moving, okay? So it's all about your frame of reference, okay? Distance is just how far an object has moved. So the SI unit for distance is meters for shorter distances and kilometers for longer distances, okay? Some of our problems will have things like miles, but generally for scientific measurement, we would want to make it in meters or kilometers, okay? So distance does not care about direction. So that's going to be different than displacement. Okay, so distance and displacement, they're very similar, but distance doesn't care about the direction or the reference point. It just calculates how far that object's moved. Displacement is distance and direction of an object and its change in position from the starting point or the origin. Okay, so we're going to do some practice problems. So a runner starts on the line 0 meter. They run to the 50-meter yard line and then, or the 50-meter line, and then back to the 20-meter line. So what's the distance? So for distance, we're just going to add up all of the measurements of what they ran. So we're going to do 50 plus, and it should be 20. I made an error. So it should be 50 plus 20. Oh, it's because the picture is 30. Okay, so it should be 50 plus 30. I made a typo up here, so this should be back to the 30-meter line. I'll fix that in your notes. Okay, so what's the runner's distance? 50 plus 30 is 80 meters. Okay, but if we want to know what's the runner's displacement, so from the starting point, okay, which was at 0, to its ending point, which if they ran up 50 and ran back 30, it would be 50 meters forward and then 30 meters backwards. So 50 minus 30, we should get 20 meters north, because if you look at the picture here, it says that we have north. So from the starting point to its ending point, the shortest distance, that would be our displacement, is 20 meters north of our starting point. Okay, just a few more practice problems. So an object moves from point A to point B to point C, back to point B, then back to point C along a line. Find the distance covered by the moving object. Okay, so from point A to point B, we move 5 kilometers, so 5 kilometers, plus we move from B to C, which is an additional 4 kilometers. Then we go from C to B, so another 4 kilometers, and then back from B to C. So another 4 kilometers, okay? And sometimes it helps to like kind of draw it out and draw each of your segments. So I would draw this segment would be 5, and then I would draw another line 4, another line over on top of that one 4, and then another one 4, and then I would add up all of those, okay? So 5 plus 4 plus 4 plus 4 is 17 kilometers. So that's its total distance. Find the magnitude and direction of the displacement of the object. Okay, so if we are going from the starting point to the ending point, okay, it doesn't matter how much they moved in between that. We just want to know what's the shortest distance from the starting point to the ending point. So we could just look at the number line, or you could have looked from A to B is 5, plus B to C is 4. Okay, or we could just look if this is at 0, our ending point is at 9 kilometers. So 9 kilometers, and we do have to add in direction. That's the big thing. Make sure anytime we have displacement that you put a direction in. So sometimes it might be right from left, it might be north, south, east, or west. Okay, for this next one, a person walks around the block. Find the distance covered by the moving person. Okay, so each of these blocks is 1 kilometer. So we can just go ahead and count the blocks that we go. Okay, so we're starting from A and walking around one time. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay, so 16, or you could have broke it up into the different things. So we had 5 plus 3 plus 5 plus 3. Okay, find the magnitude and direction of displacement. Okay, so if we started at point A and we ended at point A, our displacement is 0, because from the starting point, the shortest distance is we're already there. Okay, so it's just going to be 0. So be careful of that. Pay attention if it says distance or displacement, because sometimes displacement is going to be less than your distance. Okay, just like in this practice problem where we had our distance was 17, but our displacement was 9. So remember, displacement is just how far away are you from the starting point. So in this problem here, we started and ended here. Okay, so always be looking for, if when asking for displacement, where is your starting point, where is your ending point.